Hey, good morning again. This is a Sunday shop talk. No idea how long it'll be, and it's a vertical video because there ain't much to see. So it's a back porch video. Warm enough I can sit out here without shivering too hard, although I forgot my coffee. So, filters. What are they? What do they do? And why would I bother with the conversation, right? We know what a Brita water filter is. We know what a coffee filter is. The old drip coffee makers. We know what an air filter on a car is, or the filter on your house heating system if it's forced hot air. Gas filter on your car, one you don't think about often, ought to be changed every 100,000 miles anyway. What else have we got? Let's go back to that Brita filter. So there was a time when we had a house with a well, and one of the constituents was arsenic, and I knew that potential, and we had the well tested, and it was within limits and specs. But that can be you need to monitor that over time. So if the well hadn't been used in a while, when the samples were taken, it should have been done a few times. So I knew that was there, and other risks from farm runoff in this private well farmhouse. And yeah, you could call it a survival place. So for the house, I ended up putting in one of the best specification water filters I could afford for the whole house, so the shower and tap water was safe. And then after a year of study, I found the filtration system appropriate because those membrane filters became affordable, became consumer products instead of industrial products. So it ended up being a 3-stage filter by the tap to make sure that we had good tap drinking water, that the bulk of the water, any water we used for cooking, had gone through 2 sets of filtrations. And the first one was, the main house one was just a good spec walkthrough in selection and what we can afford, because that's the other driver. The next step up from these, $1,000, $2,000, $5,000 consumer devices are $10,000 to $100,000 commercial devices. And with those come more maintenance. So why can I speak to this? Anyone who's done work with a gas chromatograph, extensive work with a gas chromatograph, if it was a lab chromatograph, what I managed, maintained, serviced, and spec'd were industrial gas chromatographs, real-time sampling. So you didn't introduce a sample. It came from a gas line somewhere off in a process, 10 minutes away in sample time at the most, maybe. Actually, mine were all under 4 minutes. So you set up the gas flows to the analyzers. So inside that analyzer is something called my mind slips me now, capillary column, or a fractioning column. And that column's filled with, for the most part, something akin to cat litter. It's called diatomaceous earth, a very specific type of earth that as molecules go by, it talks to them. They resonate, let's say. So you get some separation, some gas separation from a set sample size up through this tube, and you measure the separations off of it. So that's a gas chromatograph. Very specific, detailed science instrument, applied engineering into chemical process areas. So that's some of the work I did and was well trained on. So this is the forethought that went into this water problem. The biggest problem was the cost of going to that next level to keep my family safe. But with that comes $30, $50 a month in maintenance. if you had to pay somebody, you've got a monthly $100 bill for maintenance. And if you pay somebody, that means somebody else knows how to maintain your stuff and not you. So somebody else gets that filter that was made in Asia somewhere that you're putting into your filter set. So I said I used the Brita model filters. There are good filters out there. You can buy straws now. That fractioning column filled with diatomaceous earth is now capillary columns, which operate on different principles. Those were becoming prevalent in labs, but our real-time machines had not started using those for a bunch of different reasons. So, but I would bet by now they're running capillary columns instead of the packed molecular sieves, which is what these are. Molecular sieves, cool word, interesting to look up. One of the ways in previous conversation about CO2 separation is the way you get the CO2 out is using molecular sieves, diatomaceous earths, carbons, charcoals. So your Brita filter, or whatever filter system you've got set up, you have to maintain it. And the more complicated that system is, the more detailed the maintenance gets. So what happens with that Brita filter is, you look and read those specifications, and that's a brand new cartridge, and then they give you it'll last 3 months or a month or change monthly, whatever the routine is. Or sometimes you taste the water, it starts to not taste good, so you change the filter out. So that's an artifact of buildup on those molecular sieves, on that charcoal, the activated carbon charcoal that will help pull some of those nasties out of the water. And it gets stored in those little charcoal briquettes down there, the micro briquettes that are inside the filter. There's paper on the outside, or felt or cloth of some sort, depending on the filter types. You've heard of bag filters. Those are typically some type of very precise cloth material, woven materials, plastics, metals, fibers, cotton. So, but all of these things load up over time. So when you get into the normal tap water thing, yes, it can help. I said normal tap water, and that's not fair, because only a third of America's tap water can be considered anywhere near normal. Maybe half of America's tap water. Infrastructure, anybody? So it comes down to that burden, that cost, that monthly recurring fee to keep your family safe is being pushed down to you, the individual. Pollution is forcing a personal tax on you. You have to pay some corporation to keep those filters on a shelf and keep those filters stocked. If you store them and have a supply, you do get into this question of loading. Are you going to have a spectrometer sitting around to see that the output of your filter is actually getting all of the arsenic out? It might be getting all of the larger particulates, but that bound arsenic in some type of compound, it's usually not just an arsenic ion hanging around. It's a compound. It bonded to something else along the way, or is looking for something to bond to, which is why it sticks to the carbon. So that was filters 101. There is a lot to that. It's talking about CO2 separation. It's talking about how the ALPS filtration system in Fukushima works. It's talking about how the Brita filter for your water works. How the coffee filter, you don't use coffee filters twice, the paper filters anyway. Well, some people do. So there's that. So, it ties back into risks. The standing alone idea, those libertarian ideals, don't fit well in the neighborhood.